Welcome to the Curious Calculator. In today's video, we're going to be going over two-way tables. Alright, so let's get started here. Two-way table. A table that allows you to organize frequencies that belong to two different categories. These two category frequencies are known as joint frequencies. Alright, and then frequency in this context is the number of times an event occurs. So let's dive in here by looking at this first table here. In this first table, what we're doing is we have the two categories. One is coffee, which is whether someone drinks coffee or not. And the second is city, and that is going to be which city someone lives in. So the two events for coffee are, well, one is yes, the other is no. And then the two events for city is city A or city B. And what we have here are the highlighted values. So the highlighted values represent the joint frequencies because they are frequencies that belong to the two categories, coffee and city. And for example here, let's see here, the 55, that represents, or that means that 55 people from city A said yes, that they do drink coffee. The 45 means that 45 people from city A said no, they do not drink coffee. And then 42 people from city B said yes, they do drink coffee. And 60 people from city B said no, they do not drink coffee. All right, and so let's look at the second table here. It looks a little bit different, but we'll go in and explain what's going on here. So the highlighted values here are going to represent marginal frequencies. Oh, got a little messy there. And the same thing with these. So these are also the marginal frequencies. All right, so how do we calculate the marginal frequencies? Well, what we do is for example, the 97, we get that by adding up the 55 plus 42. So we're adding up the joint frequencies in this first column. And then the second value, 105, we get that marginal frequency by adding up the joint frequencies in the second column. And then 100, we get that from adding up the joint frequencies in the first row. And then the 102 comes from adding up the joint frequencies in the second row. And let's notice here that this total right here, 202, that comes from adding up either these marginal frequencies here or the marginal frequencies shown here. And that 202 is equal to the total number of people surveyed. And we can also find that number by adding up the total joint frequencies. So 55 plus 45 plus 42 and plus 60, which would equal 202. Okay, so let's move on here to, now we have joint relative frequency. Joint relative frequency is the ratio of one joint frequency to the total joint frequencies, or total observations. And beginning with this table here, let's see. So we have the highlighted values here, and we get that by, well, we have the ratio of the joint frequency 55 divided by the marginal, or I'm sorry, the total joint frequencies, which is 202. And so we can see that here. So we had 55 here, and we're dividing that by the 202 here, which is the total number of observations, or the total joint frequencies. And that's what we're doing to get each of these highlighted values in this new table. So the second one, 45 divided by 202. So we did 45 divided by 202, and then 42 divided by 202, and 60 divided by 202. And then the highlighted values, those are our joint relative frequencies. And you know, actually, while I'm here, I'm actually going to write that in, that these are all the joint frequencies. And then these right here, what we were just discussing, these are the joint relative frequencies. Relative frequencies. Oops. Okay. And so now let's take a look at the second table we have here. So what these highlighted values represent are the marginal relative frequencies. So like above, how we had marginal frequencies, which we got by either adding up the values in a row or adding up the values in a column, we get the marginal relative frequencies by doing the same thing, except now the values we're adding up are not the joint frequencies, but they're the joint relative frequencies. So we call these marginal relative frequencies. Okay. And so let's look here and see that that is what we're doing. So we're adding up the 0.272 plus the 0.208, and that gives us 0.48. We add up 0.223 plus 0.297 and get 0.52. And then 0.272 plus 0.223 is 0.495. And 0.208 plus 0.297 is 0.505. Okay, so let's move on to this last little section here. Let's look at conditional relative frequency. Conditional relative frequency is the ratio of a joint relative frequency to a marginal relative frequency. Okay, so this first table here, what we're doing is we're taking, well, the joint relative frequency, and we're dividing that by the marginal relative frequencies found here, highlighted in green. And so that's why I went ahead and highlighted these green, because, well, we're getting these conditional relative frequencies, and I'll go ahead and write that, conditional relative frequencies, by taking the ratio of one of the joint relative frequencies to the marginal relative frequency found in the, this column right here. So for example, 0.272 divided by 0.495, which is right here, we get 0.549. And then we do 0.223 divided by 0.495, which is this right here, we get 0.451. And then also right here we do 0.208 divided by 0.505. So we're using this marginal relative frequency. And again, we use that same marginal relative frequency for this calculation. And now this table is the same thing. So these are also conditional relative frequencies, but we are using different marginal relative frequencies to get them. So in this one, we're using the marginal relative frequencies shown highlighted in gray here. And so we can see here that it's 0.272 divided by 0.48. So we're using this one. And then 0.208 divided by 0.48, again using this marginal relative frequency. And then in the second column, we have 0.223 divided by 0.52, now using this marginal relative frequency, and again using that same one for that column there. And so for this one, whether you're using the marginal relative frequencies highlighted in green here, or the marginal relative frequencies shown here, then it really just depends on the question or what it is that you're looking for. And that right there is going to wrap up today's video on two-way tables. And I would just like to end this with a little fun fact from philosophy. Did you know that the philosopher Jean-Paul Sartre argued that existence precedes essence, meaning that we must first exist before we can have essence.